Number 4 in this review, we need to determine the vector, parametric, and symmetric equations of the line passing through these points and perpendicular to this equation. So first step is that we know it's a line, so we're going to be using these equations. So for these coordinates, we're going to start off with the vector first. So for these coordinates, they're the normal. So since we have this point and we have this equation 2x minus 3y plus z minus 1 equals 0, we need the normal for these coordinates. So this, we're going to use this, and this would be 1z. So the normal is 2, negative 3, 1. So this is the original. So for the vector, the equation is the original. So 7, 1, negative 2, and plus t with the normal. This is the normal. Okay, that's the first equation. And for parametric, we do the same thing. So x, so we use original, and the original is from the A point. So 7 plus AT. And the A is coming from the normal, so 2t. Then for y, we get the original, which is 1, plus bt, and b comes from the normal, negative 3t. So then that's negative 3t. And then we have original z, which is negative 2, and we need ct, and the c is just 1, so it's just plus t, and that is our second equation. And for symmetric, we have these equations. So x minus the original 7 over a, which is the normal, 2, equals y minus y original 1 over normal, negative 3, and z minus original, so 2, but it would be plus 2 because you have to multiply it, so z, and then we have the normal at the bottom. So those are our 3 equations. This is the symmetric equation. This is the parametric equation. These 3 are the parametric equations. And we have our symmetric and we have a vector equation right over here. Yep. For number 5, we need to determine the Cartesian equation for each of the following. So for 5a, you're given a point. This is the Cartesian equation, and we are given point P, and we are given a normal 3 and 3. So the normal would be ABC. So we just substitute the normal into the ABC. Negative 1x plus 3y plus 3z plus d equals 0. And then we subtract this point P from the x, y, z. So we have negative 1, and then we have x minus 0 plus 3, then y minus 1 plus 3, then z minus 2, so it's plus 2, plus d equals 0. So now we use distributive property that makes this. So I just simplified everything, and now we have our equation. So when we just simplify it more, it's x minus 3y minus 3z minus 3 equals 0. So that's the Cartesian equation for 5a. Now for 5b, we need to find the Cartesian equation for some points given and an equation. So these are the points given. And this point. Those are the points given. And we have this equation. So x minus y minus z plus 1 equals 0. So we get the normal from this equation. So the normal equals 1 here, -1, -1. That's the normal. We need to find a, b to get a point. So a, b will give us 1 point, which is, that's our point and that's our normal. So now we can have our ax plus by plus cz plus d equals 0. But to get the a, b, c, that's just a vector. So we need to multiply these two vectors to get the normal to plug into a, b, c. We need to cross multiply this vector with a, b. So when we cross multiply, and the equation for cross multiplying, it's a2 b3 minus a3 b2 a3 b1 minus a1 b3 and then a1 b2 minus a2 b1. That's the equation for cross multiplying. So when we cross multiply these two, we get normal, and that's the thing we plug into ABC, and the normal would be 3, 5, -2. So now we just multiply. So now we just substitute x plus 5, y plus -2, -2z plus d equals 0. And we substitute x, y, and z with a coordinate given. So let's choose this coordinate that was given. So 3 times 3 plus 5 times 0 plus -2 times 1 plus d equals 0. And now when you simplify it, d will equal -7. So now our equation will be 3x plus 5y minus 2z minus 7 equals 0. So that's the Cartesian equation for 5b. Okay, so now for number 7, we have to find the vector and parametric equation for the plane that is parallel to the y and z plane that contains this point. So when it says it's a plane, so we use the plane equations, and it says for the y and z planes. So now when it says planes, when it's given, so a will equal the y plane, so that's just, you put 1 where the y value would be and 0. And then for b, you would put 0, 0. This is the z plane, so you put 1 here. Those are your a and b. And you are already given a point. That's the point you are given. So now to make these equations, you just substitute. So original, so you sub in the original, x, y, z. For vector equation, original is this one, plus s, you put all this in here, 0, plus t, 0, 0, 1. That's your first equation. And now we also have to find the parametric equation. So x equals x original -1 plus S1A, that will be 0, so nothing there, and TB1, so nothing there because it's 0. Okay, now we have y. Y original is 2 plus SA2, so it's S, and TB2. B2 is 0, so nothing there. And now for Z, Z original is 1 plus S, A3. A3 is 0, nothing there. And TB3 is 1, so we have plus T. So our equations are, this is our parametric equation, and this is our vector equation. I'll just highlight them in. Those are our two equations. This is another question with a Cartesian equation, number 8. So we are given a vector equation, 2, 3, 2 plus t, 1, 1, 4. And we are given this point, 4, -3, 2, and we have to find a Cartesian equation from this information. First, we need to find a normal, and to find a normal, you multiply A cross multiply B. A cross multiplied by B. So we need to find A and B. A will be this vector right here, this coordinate, 1, 1, 4, and B will be this point subtracted from this. So it's basically AR. This is R, this is the point A, we are given point A, and U. So A minus 2, 4 minus 2, -3 minus 3, 2 minus 2, this equals 2, -6, 0. So this is B. Now to find the normal, we need to cross multiply by B. This equals, when you do it, it should equal 24, 8. And the equation for cross multiplying is again A2B3 minus A3B2, A3B1 minus A1B3, and then A1B2 minus A2B1. This is the equation. So when I did that, I got this, and I could simplify this by dividing everything by 8. And when I divide everything by 8, the coordinates are 3 and 1, -1. So now this is our normal. Now we substitute this normal into the equation by plus cz plus d equals 0. We substitute it into these values. 3x plus 1y minus 1z plus d equals 0. And we could just substitute values into these. So we just get our point value we were given times -3, 2. That will give us d. So when you do it, d should equal -7. So your final equation is 3x plus y minus z minus 7 equals 0. And that will be your Cartesian equation. For number 9, you were given some following information. Number 9, we have to find the Cartesian information. We have to find the Cartesian equation from these two equations that we are given. We are given line 1 equals vector equation 4, 4, 5 plus t 5 negative 4, 6. And we're giving line 2 another vector equation of 4, 4, 5 plus s 2 minus 3 minus 4. Now we need to find the Cartesian equation. So first step is to find vectors a and b to find the normal. Okay, so a will be the value over here. So a equals 5, negative 4, 6, and b will be the value over here. These are the values we are focusing on. 2, negative 3, and negative 4. Now to find the normal, you have to cross multiply that. A cross multiplied by b will give you the normal. And when I cross multiplied, I got 34, 32, and negative 7. So with those values, I can now plug it into the equation. by plus cz plus b equals 0. So we plug these values into these, we substitute those values into ABC. So it's 34x plus 32y minus 7z plus d equals 0. Now we need to plug in values into the x, y, and z. We get the x, y, and z point from this point over here, which was given to us in the equation 4, 4, 5. So 34 times 4 plus 32 times 4 minus 7 times 5 plus d equals 0. And d should equal negative 2 to 9. So our final equation, our Cartesian equation, is 34x, 32y minus 7z minus 229 equals 0. So this is our final Cartesian equation. For question number 10, we need to find all the line equations, the vector equation, parametric equation, and symmetric equation for a line that, and we have this information here. So we have this equation we are given as Z1. So that's the equation we are given, and we are given this point. 2, 3, negative 3. That's the information we're given. From the equation, we can get the normal, which is 3, negative 2, and 2. That's the normal, and we have this point. So to start off, for the vector equation, we substitute the point into the original's vector thing. So we substitute the point plus t and the normal. That's the normal, and so that's the vector equation. Now we need to find the parametric equation. So x equals x original, so we get the original from this point 2 plus at, and a is from the normal, plus 3t. So that's our x. Now we need for y, we have y original, which is 3 minus 2t. And for the last one, z, negative 3 plus t. Okay.
বলছি জানো বনবন রয়েছে আমি তোমায় কত করে বললাম ওরে বাবা বাগানে বাগানে